Alright, 1.7 transformation of functions is what we're looking at today, and we're going to be talking about moving graphs around based on the parent functions that we learned on our last section. So, for example, x squared plus 2. The parent function of this would be x squared. If we had h of x equals x squared, that's a parabola. It looks like this. What we're going to learn today is what do we do with the plus 2 and the minus 2 if it's inside the function, like here, or if it's outside the function, like over here. In this case, on the top example here, the x squared plus 2, that's going to be a vertical shift. We're going to go up 2 and have our parabola. On the second example, where we have x minus 2 squared, this is going to be a horizontal shift. Horizontal shifts, we always go the opposite of the sign. So since it's a minus 2, we're going to go opposite of that plus 2. We're going to go to the right 2 and have a parabola like that. So let's take a look at our first example. Actually, before that, here is what I just said written out. It's a good thing to go back and look at. Vertical shift has the plus and minus written outside of the f of x, and the horizontal shift, again, it's opposite. If we're going to the right, we'll go minus c. If we're going to the left, we'll go plus c, and that's going to be inside the parentheses for a horizontal shift. Alright, so our first example, we want to take our parent function of x cubed. So let's real quick just remember what that looks like from our parent function list. That's our graph for y equals x cubed. So let's go ahead and see what happens if we say minus 1. This minus 1 is outside of the x. It's not inside the parentheses with it, so that's a horizontal shift, and we're going to go down 1. So normally we would cross right here at 0. We're going to go down 1, and that's going to be our shift. And for our second one, we've got two shifts going on here. We have a vertical, up 1, and in here we're going to go left 2. So we're going to go up 1 and left 2, and that becomes our important point on which we're transitioning our x cubed graph. So let's see if you can do this on your own. Go ahead and take a stab at problem 7 from your textbook. Pause me when you're ready to go. I will put up an answer. Alright, if you're ready to go, let's take a look for A. They said use 3 different ones, so we're going to go absolute value of x plus negative 1 plus 1 and plus 3. 3 different options here. These are all vertical shifts. So our first one, down 1, absolute value, we'll hit like that. Up 1 for our second one, we're going to hit like that, and then up 3 for our third. And so same exact graph, just shifted a little bit in each case. For B, same thing. On all of these, we're just going to be shifted left and right by varying amounts. If we put a minus 1 in here, that's going to become a plus 1, and we always do the opposite. So our first one will be shifted to the left by 1. If we put a positive 1 in here, we'll have negative 1. Opposite goes over here, shifted to the right 1, and the last option is shifted right 3. Like that. And our third option, every single one is going to be shifted to the left by 4. So 4 is our important point, and then it will look exactly like problem A from there. So shifted down 1, shifted up 1, just looking at the vertices, shifted up 3. We have 3 distinct absolute value graphs.